Okay, we are going to solve problem 15.3 part A of Sadiku book, and the question is to find the Laplace transform of e to the minus 2t cosine of 3t ut. And I will present two ways to do this, and the easiest way is to look at Laplace transform lookup table. So here we have e to the minus 80 cosine omega t and ut. Ut means that this function is defined on t greater than 0. When t is less than 0, the value of this function will be 0. And that's exactly what this table said. Define for t greater than or equal to 0. And when t is less than 0, the function will be 0. So we can use this table to solve this Laplace transform. So here we have e to the minus 80. So the Laplace transform, let's write what's on the table. The Laplace transform of e to the minus 80 cosine omega t is equal to s plus a over the quantity of s plus a squared plus omega. Okay, here is what is on the table, and let's put the table out. So here we have this, and the value of a, so a is 2 from here, and 3t, the omega is 3. Okay, we will have omega is 3, and what we do is we just plug a and omega to this one. So the Laplace transform of this will equal to s plus 2 over the quantity of s plus a squared plus, oh sorry, this is omega squared, so we will have 3 squared, and a is 2, or we can square this 3, so we will have s plus 2 divided by s plus 2 squared plus 9. So this is the Laplace transform of this function from the lookup table. Okay, now what if you don't have access to the lookup table? So we need to derive it. Okay, I will clean the board and let's see how we derive it. Okay, that now we have cleaned the board, so we will derive the Laplace transform of this from the definition of Laplace transform. So the definition of Laplace transform is integral from 0 to infinity of the function that we want to transform. So e to the minus 2t cosine 3t ut, and it's multiplied by e to the minus st dt. Okay, now the first term that we can remove is this ut. Why? Because ut is defined by 0 when t is less than 0, and 1 if t is greater than or equal than 0. Okay, because of these two functions and our limit of integration is from 0 to infinity, so we only need the value of this to be 1. So we can, it's simply this function multiplied by 1. So we can rewrite this as simply integral of 0 to infinity e to the minus 2t cosine 3t multiplied by e to the minus st dt. Okay, now we can combine this exponential term. So this is e to the minus 2t and this is e to the minus st. So let's rewrite this as integral of 0 to infinity e to the minus, okay, I want to factor out minus 1, so s plus 2t cosine of 3t dt. Okay, now we are going to integrate this using integration by parts. So this is our u and this is our dv. Okay, we need du from here. So du will be the derivative of this one. So we will have e to the minus s plus 2t, but by the chain rule we need to multiply the derivative of this in parentheses, so it is minus s plus 2. So here du will equal to this dt, dt, and here is our dv, so we need to integrate this to get v, and the integration of that one becomes 1/3 sine 3t dt. Okay, now we need to plug into integral of u dv is equal to uv minus integral v du. Okay, let's plug all of the parts to this formula and let's see what we get. So we plug in u, so I will have e to the minus s plus 2t and v, so this will be over 3 multiplied by sine 3t. Okay, and do not forget the limit of integration from 0 to infinity, and minus integral from 0 to infinity v. V is this 1/3 sine, and dv will be this one, and I want to cancel out this minus with this minus, so I will have this s plus, and we will have s plus 2 e to the minus s plus 2t, and okay, we will have this sine, v, so this is over 3 and then sine 3t dt. Okay, I need to rewrite this because this is hard to see. Okay, I will clean the board and rewrite this and we will continue. Okay, so far we have derived this part, so this will equal to this by using integration by parts. And let's plug the limit of integration of this. So this is e to the minus infinity, and that will equal to 0. And for 0, we will have sine 0, which is also equal to 0. So we will have 0 minus 0 from this one. So this will equal to 0. So we only need to take care of this. And here we have this is a constant and this is integral. So we can put out the constant outside of the integral. So we can put the integral sign here. And we can erase this, and because this is equal to 0, we can erase this. Okay, now we have these integrals similar from before, and again we can use integration by parts. So this is our u and this is our dv. So what is our du? Our du is the derivative of this one, so it will be minus s plus 2 times t, times e to the minus s plus 2t dt, and v will be the integration of this one, which is minus 1/3 cosine of 3t. Okay, we need to plug into the integral formula, so that will be long, so I will start from here. uv. Okay, now we will have u times v, which is minus e to the minus s plus 2 t divided by 3 of cosine 3t, and do not forget the limit of integration from 0 to infinity, and then minus v du. So our v is this and our du is this, because this minus and minus sign will cancel each other, so the sign will be still minus. Okay, now we will have this s plus 2 over 3, and then this one e to the minus s plus 2t cosine of 3t dt, and the limit of integration is 0 to infinity. And don't forget that this is only the integration part, so we need to multiply all of this with this one, the constant. So I will put it here. I will have s plus 2 over 3 and our big parenthesis here, and let's calculate this one. So this is our uv parts, and if we plug infinity here, we will get 0, because this e to the minus this one will be 0, and when it is 0, cosine 0 will be 1, and this will be 1/3. So I will have this term here is equal to 0 minus 1/3. I mean 0 minus 1/3. So all of this will cancel out to 1/3. And here we can do again that this is a constant, so we can put this out of integration. So we will have s plus 2 over 3 integral from 0 to infinity. Okay, and if we take a look at this, and this is actually the integral that we are looking of, so it is equal to this one. So let's name this integral is I. So this will also be I. So we will have a very simple equation. So I will have I is equal to this one, s plus 2 over 3, and then this will equal to 1/3, so this is 1/3, and then minus this one will be s plus 2 over 3 multiplied by I. Okay, so now we only need to solve this for I, and we will see what will the result. Okay, let's clean the board. Okay, now we can solve this equation for I, and let's do that. So we can multiply by the multiplicative inverse of this constant. So I will have 3 over s plus 2 times I, and that will cancel this, and this will be 1 over 3 minus s plus 2 over 3 of I. So I want to isolate I, so I can move this to the left hand side. So I will have 3 over s plus 2 plus s plus 2 over 3. Okay, I can remove the parentheses because it's not needed.
Ya, jadi kita kayak pegawai-pegawainya gitu.
And all of this multiplied by I.
Boleh.
And that will equal to 1/3. Okay, now we can manipulate this. So that will be this time this time this over this time this. Okay, now we will have 9 plus s plus 2 squared divided by 3 over s plus 2 of I, that will equal to 1/3. And finally we can solve for I. So we will have I is equal to 1/3 times 3 s plus 2 over s plus 2 squared plus 9. And we can cancel this 3. And finally, the Laplace transform of this function will be s plus 2 over s plus 2 squared plus 9, which is the same from what we get from the Laplace transform table. Okay, thank you for watching, and let me know if I did any mistake in the calculation. Thank you.